This is 2021 paper 2 question 5. We have two cones inside of a sphere. We're told to prove that the volume of the remaining space inside the sphere is half the total volume of the sphere. Okay, so basically what we need to do is show that all of this space outside of the cones is half the volume of the sphere. So another way of doing that is we can prove that the cones have a volume that's half the volume of a sphere. Well, that means that the green stuff is also half the volume of a sphere, because then you add them together and you get the full sphere. So that's what we're going to do. So for the volume of the cones, these two formulae are in the tables booklet. Well, if we look at the volume of a cone, we have 1 over 3 pi r squared, and then the height of the cone is actually also just a radius of the sphere. If you look here, that's also just a radius of the sphere. So the height is just the radius. And we have two cones. So that means that we have 2 over 3. So that's just multiplying this thing by 2. Pi r cubed. Okay, so that's the volume of two cones. Now the volume of the sphere, as we have up here, is 4 over 3 pi r cubed. That's given in the tables booklet. So we can say that therefore the volume of the, did they say the remaining area? Is that how they said it? Yeah, the remaining space. So the volume of the remaining space will be the volume of the sphere minus the two volumes of the cones. So that'll be 4 over 3 pi r cubed. And the volume of the two cones is 2 over 3 pi r cubed. So that's going to give us 2 over 3 pi r cubed, which is the same as the volume of the two cones. That's what they asked us to show. So, they said half the volume of the sphere, not the volume of the two cones. So 2 over 3 pi r cubed, well, that's the same as doing half the volume of the sphere, because remember that the volume of the sphere was 4 over 3 pi r cubed. So we said that the volume of the remaining space is equal to half of the volume of the sphere, which is exactly what they asked for. Then we're told the volume of the two cones combined together. So remember that the volume of two cones was 2 over 3 pi r cubed. So we take this, and we know that that's going to be equal to 686 over 3 pi. So then we have a 3. Well, we can divide both sides by pi and they cancel out. Multiply both sides by 3 and they cancel out. Then you can divide both sides by 2. And when you do that, you'll get the r cubed is equal to 343. So that's dividing this by 2, dividing this by 2. Then cube root both sides, and you get that r is exactly equal to 7. And the unit we're talking about is centimeters, because the volume was centimeters cubed. And it says find the radius of one of the cones, but we never said, obviously you can't really combine the radius. So when we found r, that's just the radius of one of the cones. So yeah. Then we have a question about distance, speed, and time. So we have one van going towards a factory at 60 kilometers per hour and another one going at 95, and the other one leaves an hour and 45 minutes later. So you could draw a graph and find out where the two lines intersect, something like that. What I'm going to do is basically the same thing, except I'm just going to do it completely algebraically because it's a little bit faster. So we know since they end up at the same destination, that means that the distance they travel must be equal. So the distance traveled by A must be the same as the distance traveled by B. Now remember that distance is speed multiplied by time, and that's because speed is distance divided by time, so you can multiply across and get that. So that means that we have the speed of A times the time that A spent traveling will be equal to the speed of B multiplied by the time that B spent traveling. So the speed of A then is 60, so we'll have 60. The time that A spent traveling, we can just call that T, and that'll be equal to the time, or the speed that B was traveling at, which is 95, multiplied by the time that B spent traveling. So B spent T hours traveling, but it started 1.75 hours late. I've just written that as a decimal, just because it's a little bit easier, but you could say it's 1 and then 45/60ths of an hour, which is the same as 1.75. It's kind of up to you. So B basically spent T hours traveling minus 1.75, because it spent whatever A spent, which is T, but 1.75 less than that. So that's how we do that, and then we can just solve this equation. So we can just multiply out the bracket, and we'll get 60T is equal to 95T minus 166.25. Then we can bring everything to the one side. We get 166.25. So I brought the 166 to the other side. That'll be equal to 35T. Divide both sides by 35, and you get that T will be equal to 166.25 divided by 35, and you get 4.75. And everything here was in hours. This is 1.75 hours, and this was in kilometers per hour. So this is going to be in hours. And then T was the time that A spent traveling. So A left at 9 a.m. and then it spent 4.75 hours traveling. So that's 4 hours and 45 minutes after 9 a.m. So then, 4 hours after 9 a.m. is 13, if we write it in military time, but you can kind of write it whatever way you want. So it'll be 13:45 when they arrive.